So much like binomial, we're going to be calculating the expectation. And by that I mean the expected number of successes for a certain number of trials. So we're going to do it for one trial, then we're going to expand it to n trials. So for one trial, the number of successes we could possibly have, it's pretty limited, right? So either we are going to have 0 successes or we're going to have 1 success after one trial. Now the probability of having a success, remember in the pool, we have A successes out of a total of T outcomes available, so the probability is going to be A over T. Technically we could calculate the probability over there. This would be T minus A over T, but it doesn't really matter too much because 0 times that is 0. And 1 times A over T is A over T, which means that for one trial we expect to have A over T successes. Now, when we have, what we're going to say is we're going to say that kind of like binomial. So binomial, the probability definitely stays the same. What we're going to say is that for a hypergeometric distribution, that the probability of success roughly stays the same. And that's not a very strict mathematical proof in any way, shape, or form, but it's what we're going to go with right now. And so what that means is that our formula is going to be that the expected number of successes after n trials is going to be the number of trials times A over T. And that's going to be our expectation formula for a hypergeometric distribution. Let's do an example. So we have a box with candies, and 4 of them are red, 5 are blue, 6 are yellow. If we grab 5 candies at once, what's the probability that 3 are yellow? And you can probably pause this and try to figure it out yourself. So we're going to write down the 5 things. So success, N, A, am I still on screen? Yep. X. So success here is, we want to grab 3 that are yellow. So we're calling yellow a success. And we're grabbing 5 candies. Now how many successes are in this pool? Well, since success is yellow, there's 6 successes walking around. There's a total of 409 plus 6, 15. And we're looking for 3 of those. So the overall probability that x equals 3 is going to be 6 choose 3, and then I'm going to cut the calculations. I'm going to do subtractions in my head, which would be 6 choose 3 times 9 choose 2 divided by 15 choose 5. So I got 23.97, so about 24.0%. Okay. What is the expected number of red candies, which we will get if we grab 3 from the box? So you'll notice I changed the color. Now we're looking for the red ones. So once again, we'll write down success, N, A, T, X. And now success is going to be red. We're grabbing, so N is going to be 3 because we're grabbing 3 from the box. The number of reds was, where did it go? Number of reds was 4. And the total number of candies was 15. And so, and x is what we're trying to find. So this is kind of a non-applicable, right? That's what we're trying to find. So if we're trying to find how many do we expect, if we're trying to find an expectation, x doesn't really, it's not really a thing that we're going to look at. And then the formula for expectation is NA over T, which is 3 times 4 over 15, which is 12 over 15, which is 0.8, which is not a percentage. If you answered 80%, that would be wrong. We expect to get 0.8. If we grab 3 candies from the box, we expect to get 0.8 red candies. We can actually try that. We're going to try to get the same answer. We're going to do it with an XPX table. That's what we're going to do over here. So let's say we didn't have that handy dandy formula of NA over T, and we tried to do it like this. So we have our X, our P of X, which was going to need a lot of space, and then our XP of X. So we have we have 3. We're going to be drawing 3 candies. We want to get red, so we can either have 0, 1, 2, or 3 successes, where X is the number of reds. And I'll start with the top over there. So we could say that, so for 3 candies, the probability is going to be 4 reds, and there's 11 other candies. On 15, choose 3. And this one is going to be 4, choose 2, times 11, choose 1. On 15, choose 3. And this is going to be 4, choose 1, times 11, choose 2. All on 15, choose 3. This one doesn't matter because we're going to multiply it by 0, but for fun, we want no reds, 3 of the other 11. So this is going to give us 4 divided by 15, choose 3. So, actually, okay, 4 divided by 15, choose 3, which is going to be 0.00879. That's going to be the probability of that one. 4, choose 2, times 11, divided by 15, choose 3. That's 14.5%. 4 times 11, choose 2, divided by 15, choose 3. Is 0.484. And the last one should probably be, hopefully, something 1, choose 3 divided by 15. And that's going to give us 36.3. Okay, and then we do that. So this time this is going to give us 0. 0.484 times 1 is going to be, I'll round it to 1 decimal, 0.48. 0.145 times 2 is going to be 0.29, and 0.00879 times 3 is about 0.03. And if we add those all together, our expectation is going to be 0.48 plus 0.32, I'd kind of that together, is 0.8. And look at that. We got the exact same answer as before in a much more horrible way. Right, so this is why this formula is so wonderful. So we just did this and we got 0.8, but if we had done it the long way, we still would have gotten 0.8. Okay. What's the probability you will grab at most 1 blue if you grab 7 candies? So we'll set it up. Success N A T X. So success is that we get a blue. We're grabbing 7 candies. The number of blues available are 5. There's still a total of 15 candies in here. And we want to grab at most 1 blue. So if we want to grab at most 1 blue, we could grab 0 blues or 1 blue. So we're going to have cases. We're going to have the probability x equals 0 and the probability x equals 1. And we're going to add those together. So I'm going to do it a little quickly. So that's going to be 5 choose 1 times 10 choose 6 over 15 choose 7. This is going to be 5 choose 0 times 10 choose 7 over 15 choose 7. So 10 choose 6 times 5. So that's going to be, did I do the right thing there? Times 10 choose 6. Yep. Divided by 15 choose 7. So I got 16.3% for that. And then I got, for this one, it's going to be 10 choose 7 divided by 15 choose 7, which is going to be 1.9%. And if we add those together, it's going to give us a total of 18.2%. And so the probability of getting at most 1 blue if you grab 7 candies is going to be 18.2%.